Today, we're going to break down Lumera, a project that's trying to do something a little different. Instead of just building another app, they're aiming to build the actual infrastructure for a whole new generation of decentralized artificial intelligence.
Okay, so let's just start with the biggest question that frames this whole problem. The AI industry is absolutely exploding, right? But it's almost completely dependent on just a handful of massive cloud providers. So how can you build powerful AI that's meant to last without being at the mercy of big tech?
Well, the answer seems to lie in this concept of horizontal innovation. You see, we get a lot of chains like Ethereum that are all about running applications. But there's been way less focus on building dedicated chains that are just really good at one thing, providing resources to those other chains, things like storage and computation. And that's exactly the gap Lumera is trying to fill.
And that brings us right to the proposed solution, a purpose-built AI cloud. So let's get into Lumera and see how it's designed from the ground up to tackle this huge resource problem for AI.
At its heart, Lumera is a decentralized cloud built specifically for AI. Its whole mission is to provide these verifiable, trustless services. Think about it: permanent data storage for huge AI models and massive data sets, and all the computational power you need to actually run them. It means AI applications built on this can't just be shut down or have their access pulled by some company. It's meant to be a permanent home for AI.
You know, what's really interesting is Lumera's origin story. It actually started as a project called Pastel Network, which was a fork of Bitcoin. But the team pretty quickly ran into some serious performance issues. So they made this huge, crucial decision to pivot, rebuilding the entire thing on the Cosmos SDK, a way more modern, high-performance framework. And that's what became Lumera.
But this move wasn't just about getting faster. It also opened up the door to what is really Lumera's key innovation, a new way to prove that complex work is actually being done on the network. It goes a step beyond just making sure the ledger is secure.
Okay, first, let's just set a quick baseline. Most modern blockchains, especially in the Cosmos ecosystem, use proof of stake. Validators lock up capital, their stake, to secure the network. And it's an amazing system for answering one super important question: who owns what?
Right, but here's the thing. Securing balances is one thing. But how do you guarantee in a totally trustless way that a really complex AI model was run correctly, or that a petabyte of data is still being stored exactly as it should be? Just answering who owns what isn't enough for that.
And that's where Lumera introduces what they call proof of service. It's basically an extension of the consensus mechanism. It's designed not just to secure the ledger, but to actively verify the services the network is supposed to be providing. It answers that other critical question: who did the work?
And this quote from Anthony at Lumera, it just sums up their whole philosophy perfectly. The idea is that having a secure network is great, but it's kind of meaningless if you can't prove that the network is actually delivering on its promises. For a network built to provide services, verifying the work is every bit as important as verifying the transactions.
So how does the network actually pull all this off? Well, this whole idea of verifying work kind of requires a two-tiered system of operators. And this structure really defines the whole network. The network is basically split into two different jobs. First, you've got your validators. They do exactly what you'd expect on a proof-of-stake chain. They secure the network. But then you have this second layer, the supernodes. These are the high-powered machines doing all the actual heavy lifting, the data storage, the computation, the AI model inference that users are paying for. And make no mistake, running a SuperNode is a serious business. This is not some passive hobby you can do on an old laptop. It requires a significant financial stake in the network, some really powerful and redundant hardware, and a business-like approach to make sure your uptime is rock solid. The whole system is designed to favor a small number of great, reliable operators over a huge number of weak ones.
So this brings us to the economics of it all. You've got two different types of operators doing two very different jobs. How are they all incentivized, and what makes this whole ecosystem sustainable for the long haul? The design here is actually a really clever dual reward system. Your validators earn rewards from network inflation for securing the chain, pretty standard for a proof-of-stake network. But the supernodes, they earn their keep directly from the fees that users pay for services. So when a developer pays to run an AI model, that fee goes almost entirely to the SuperNode operator who did the work.
And at the center of this entire economic engine is the native token, Loom. It's described perfectly here. It's not just a speculative asset. It's the oil that fuels every single action on the network.
The token's utility is really baked into every part of the system. It's used for staking to secure the network, it's required as a bond just to become a SuperNode operator, and maybe most importantly, it's the only currency you can use to pay for the network's core services. This creates a really direct link between how much the network is used and the economic demand for the token itself.
And all of this creates a pretty powerful economic flywheel. In the beginning, inflation rewards help bootstrap the network and get people to secure it. Then, as usage starts to grow, those service fees become the main economic driver, rewarding the supernodes for their hard work. And then, a little piece of those fees gets burned, which over time can create a deflationary effect as the network gets more and more use. It's a system that's designed to adapt.
So, where is all this actually going? Let's take a look at the long-term vision. For Lumera, success isn't just about launching a mainnet. It's about becoming an unquestioned, default piece of infrastructure for developers building the next generation of the internet.
By 2026, the goal is to have multiple real-world AI applications running on the network every single day. And critically, the network needs to be sustainable, meaning supernodes are earning more from actual user fees than from those early inflation rewards. But the ultimate sign of success? When developers just automatically reach for Lumera because they know it's the most reliable, censorship-resistant way to power their AI apps, the same way they reach for something like IPFS or Arweave today.
And a key health metric for the network is hitting this number, a 66% bonding rate. This is a pretty common standard in the Cosmos ecosystem, and if they achieve it, it signals a really mature, highly secure network, where the token holders are deeply invested and economically aligned with its long-term success.
Which leaves us with one last big thought. By successfully separating the job of providing resources from the job of running applications, projects like Lumera are really laying the foundation for a more modular, more resilient, and more decentralized internet. They're not just building another app, they're building one of the building blocks. So the real question is, what new worlds will be built when developers finally have permanent, uncensorable infrastructure to power their most ambitious ideas?